Our first online class. From previous class, I touched something on solid phase microextraction. We saw the videos and everything, and we know already that it requires something like a pen, whereby inside the pen we will have an adsorbent over here, which is coated with a polymeric supporting material. This polymeric supporting material is actually the extraction phase, whereby it will look something like this. So when this is your analyte compounds in vapor phase, so it will go and absorb themselves on the fiber over here. Why they can absorb themselves? Because the fiber over here is actually non-polar coating. So these compounds, if it's non-polar, they will absorb and also enrich themselves. So this is in head space. Everything is in gas phase. Here basically before reaching any solution. Then how do we want to dissolve it? We discussed last few days. We will use desorption in hot injector, or we call it as thermal desorption injector. So after this, finish everything here. That's what we said, something like having 2 steps for SPME. That's why it's very good. So this is the SPME fiber assembly that I asked you guys to look into in the internet, whereby you can see that polydimethylsiloxane, carbowax, polyacrylate, actually the same materials been used in the GC capillary. Have a look on it. I hope you still remember what is the properties of polydimethylsiloxane. They are non-polar, therefore it is recommended for non-polar semi-volatiles. And then we start on this, right? So the principle of SPME, the amount of analyte absorbed by the coating at equilibrium is related to the concentration. The keyword is concentration of the analyte. This is the equation whereby N equals to KFS. What is KFS? Is the partition coefficient for the analyte between the sample matrix and coating. And then we have the volume of coating. And this is usually microliters lah. CO. Initial concentration of analyte in sample and volume of sample, divide by, if you see from here again, partition coefficient, volume of coating, and plus VS. If you been following my class, I always told you that during when you want to see whether which one is it directly related or indirectly related, always see the numerator and denominator. Here the denominator, if it's plus VS, is going to make the denominator big, right? So if something small divided by something big, is going to give you small one. So the next one, comparison between Econom SPME and Solid. So this Econom SPME is actually coming from the research material. This is actually developed in our lab, few years ago, and we compare it with the Solid. So this is the shortest Solid that we can do lah, but usually it will go up to 16 hours and so on. Extraction time for SPME, you can see that it's only 20 minutes, but we did have something like 10 minutes over here, depending on analyte. And organic solvent is none, while Solid is 200 ml. Why do you think it's none? Remember when I show you the diagram, there's only 2 steps. One is extraction, the next one is only desorption, right? And it's only using gas, so nothing whatsoever using organic solvent. That's the best part of it. No organic solvent, therefore this is totally green, towards green chemistry. Solvent cost per year, of course none. This is how you foresee your solvent cost. Electricity, This is more because you use more heating. Thimble fiber, you are using more thimble over here. This is using fiber in the SPME fiber. Okay, manpower 22,000 is when you are doing 6 hours. Imagine if you are doing 16 hours. And total cost is only 2,000, and this one is 29. Why 2,000? Because as I said few days ago, the SPME fiber can cost you up to 600 or 1,000 ringgit. Everything else is the labor. Okay, so this is the example of chromatogram. Okay, in a GC run, I think. Okay, you imagine. Okay, the sample is fruit punch flavor. So flavor is something that is volatile. That's why you can taste, that's why you can smell, right? So it is suitable for headspace SPME. Okay, if you direct inject it, okay, see over here, if you direct inject it, we can see that the peak rate over here is really wide, really wide, which we don't want in a chromatogram, right? But after you extract from headspace SPME, headspace, not direct immersion, you can get a very good peak, okay, and more peak actually. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here something is missing here. Why? Maybe because this is actually interference from the beginning. So when you do headspace SPME, the interference is gone. Okay, here glycerin is also gone because glycerin is the interference. Another one, my favorite analyte example, amphetamine and methamphetamine in urine. Okay, the SPME fiber is actually non-polar. Okay, so still remember how to make sure amphetamine is neutral during this extraction. I hope you still remember. Okay, means that this amphetamine must be in a solution that is having pH above its pKa, so that it's going to be neutral. Then when it is heated in the GC unit, it will volatilize the amphetamine analyte over here. So this is in urine. See, the fiber is polydimethyl siloxane. It's non-polar, nothing to do with ion exchange whatsoever. Okay, so this is how they do extraction. They have to heat up until 80 degrees C because amphetamine is a drug that is not easily volatilized, but can still volatile them up by heating. Okay, if you remember from the video, we can heat it. We incubate for 20 minutes, dissolve for 3 minutes in the TDO, and then you can go and do your GC. So this is regular coffee grounds. So coffee, you can smell it. Of course, it's vaporizable. Okay. So over here, desorption at 270, headspace for 30 minutes at 65. Okay. And then this is actually the GCMS. You can see how many compounds actually in a coffee ground, up to 57 compounds. And SPME can extract them all. So this is the automated SPME connected to GCMS. Okay, the one that I show you in the video. The brand is MPS over here, very famous. And the brand for the SPME is Gerstel. So Gerstel is actually the one is selling SPME a lot in the world right now. Okay, that's all for SPME. Next lecture will be relating to the advanced liquid and solid extraction. Thank you.